Hello everyone, my name is Ilya. I'm pre-sale engineer at StreamLabs, and today I will conduct this webinar. We are very pleased that you took your time and joined us in such an uncertain situation when the whole world is gripped by an incredible pandemic, what definitely affects each one of us. We're glad to welcome you here and hope that you, just like us, are taking all necessary measures to protect your health as well as the health of your relatives and friends. The topic of our today's webinar is new features in multi-screen and MultiRec. So first, I will tell a little about the company, and then I move on to the key new features of the software. And in the end, I will answer your questions. Now I will switch off my camera so that it will be more convenient for you to watch the presentation. Well, a few words about the company. The company started as a developer and manufacturer of circuit boards for input and output of TV signals. Now StreamLabs is internationally renowned software developer for the broadcast. We have experience in such areas as monitoring and compliance, video surveillance, telemedicine, playout and ingest systems, automation of TV channels, monitoring of large broadcasting networks, solutions for early warning systems. We are also working on developing of AI features for our software. We are really proud of numerous installations around the world. Our offices are located in Russia, Latvia, and we have representatives in USA, Latin America, and India. Our clients are television channels of various sizes, system integrators, well-known telecommunication operators, and media holdings. After the pandemic began, we quickly switched to remote work, but it has not affected the pace and scale of development. At these difficult times, we still provide 24/7 technical support to our customers as it used to be. Support and develop our existing products and develop new solutions as well. At the same time, we evaluate the market needs. Well, now let's move on to the topic of today's webinar, one of our flagship product, StreamLabs. StreamLabs allows both visual and control and monitoring of various types of video and audio sources, TV services, TV channels, and transport streams. StreamLabs can provide monitoring and quality control of central and regional network installations. Server can be configured and designed for any specific task at hand. For example, to control terrestrial, satellite, or cable broadcasting, transport streams, or baseband signals. At the same time, you can have ASI inputs or control OTT streams like HLS. Key features of StreamLabs are support of various types of signals, support of large number of formats, a customizable system, easy scaling, control of large number of parameters and flexible alarm settings, unified database for several servers, work with external systems via SNMP, showing signals from one server on several displays, fully remote and centralized management, what is quite important in current situation. In general, the system can be divided in two components. Visual mode, when pictures are gathered in a mosaic on a display, and monitoring mode, based on a deep analysis of parameters for input signals. Visual mode consists of mosaic screen, states panel, and penalty screen. Now we will tell you a little about each one. Mosaic screen is quite a common thing, but it has some additional features, which can be configured in a built-in graphics editor. For example, it allows to display alarm history, look up stream parameters, overlay teletext and subtitles, show EPG data or SCTE marks. This slide shows an example of the states. The color of each element may vary and depends on a certain status of the channel. It can be green, red, yellow, orange, etc. This allows the operator to identify a problem faster, especially when he works with large number of screens with mosaics. In case of penalty screen mode, if errors or an outage occurs on any service, it will be shown on the penalty screen automatically. At the same time, color-coded field with information appears under the image with the name of detected alarm event. As shown on the slide, for example, freezing or incorrect sound level. Also, operator can manually send the service on the penalty screen for fast lookup. An important distinction from other multi-viewers is that our system allows not only to capture and display the signals on the video wall, but also to control a number of various important parameters. It provides an intelligent analysis in more than 36 different parameters. These are numerous measurements of quality of service for transport streams, including metrics for under TR290. At the same time, there are metrics for quality of experience, like freezing, black screen, blocking picture, and there is also a monitoring for audio level compliance by EBU 128, volume normalization control. Also, the system has a model for receiving SNMP trap from various third-party devices. Another thing is a metadata control. You can display and control data from EIT table as well as EPG, teletext, subtitles, and SCTE marks. So here we can now see new functionality in MultiScreen. As you know, everything is moving to IP. At the same time, more and more UHD channels appear, and production of video content is constantly growing. Of course, this brings the need to control it at all stages, including the stage of production itself. So that's why we decided to move in this direction. But at all stages, production, as well as head-ends, there are still a lot of uncompressed baseband signals sources like SDI, cameras, switchers, distributors, and classic playout servers. To date, uncompressed UHD can be in two well-known variations, quad-link 3G SDI and 12G SDI. As the demands for UHD formats evolve, media industry is facing the need to upgrade all equipment, and UHD requires 4 times more bandwidth than HD. Therefore, there is a need to replace devices with 3G SDI and install new equipment with 12G support. But if the company is not ready to change its infrastructure at a time, then the quad SDI interface can be a solution. It's a combination of 4 3G SDI interfaces where each one is handling a quarter of the UHD video. These 4 signals are combined to create a common image with UHD resolution that runs at 12G SDI. A big advantage of this method is an ability to use existing infrastructure and equipment. For such companies, we decided to integrate Blackmagic decoding cards, which allows receiving quad-link 3G SDI and combining them into a unified UHD image. So such UHD signals are controlled along with other types of signals. And if necessary, we can encode quad SDI and stream it out both as a part of a mosaic and as a separate signal. On the other hand, if everything is already built on 12G SDI, we are also ready to get it under control. 12G SDI has 8 times wider bandwidth than regular HD SDI, but it still allows you to connect with only one cable. It is regularly used on live TV events, studios, and on-site filming when reducing the number of cables and reducing the number of connections points really matters. Integrating decoding cards also allowed us to use 12G SDI signals. And here as well, we can encode and stream 12G signal over the network as a part of a mosaic or on its own. It may be an MPEG-TS, HLS, and now also NDI stream, which I will talk about a bit later. Restreaming option can be useful both for remote monitoring and for outputting any of the mosaics within the local network. High definition formats with high bandwidth, need for flexible signal delivery, easy deployment of distributed broadcasting, all this has become the major signs for moving of uncompressed video to IP channels. Now, there are several standards for transmission of professional video over IP. One of them is SMPTE 2022-6, which describes the encapsulation of an SDI signal. For TV standards and studios using SDI over IP, we have developed an integration with Mellanox RiverMux network adapter. Using a high-performance network card driver, StreamLabs is able to receive and de-encapsulate 2022-6 signals. The resulting video image, along with other formats, is added to monitored parameters and viewed on a mosaic. On this slide, you can see that new types of sources are being added as before in the multi-monitor. Here we configure the parameters for reception of SDI over IP. You can also see in the checkbox new types of UHD SDI sources for 12G and Quad SDI. These sources have list of standard alarms similar to another sources: signal loss, image freezing, pixelization, black screen, low audio level, and other parameters that are already familiar to you in other types of sources. We didn't ignore another popular standard used in media industry, namely NDI. NDI is a free standard developed by NewTek. It allows video systems to communicate with each other via an IP connection for encoding, converting, and receiving multiple video and audio signals with minimal delay. NDI standard works over gigabit Ethernet networks. There are also various cloud implementations of NDI using the SRT protocol, which makes possible to use the standard for remote filming of various events like broadcasting and teleconferences. Obviously, output signal needs to be monitored at all of these distributed sites. For these purposes, we integrated the NDI standard into MultiScreen software. Same as others, NDI can be put on the mosaic screen or transcoded for TS to TS for restreaming. Another new feature is that we implemented is streaming mosaic over NDI, which means you don't need a separate server to have it on the screen. Software-based NDI player would be enough. So, we can create a mosaic window and stream it to the network over NDI. In order to do this, simply select the appropriate option in the multi-monitor interface and assign an identifier to the window sender name. At the reception point, select the appropriate NDI identifier. Currently, this is especially relevant because you can easily switch the signal to the backup control room while the main one is being sanitized. So, you can easily duplicate all mosaic panels without spending money on additional server equipment. You can also create NDI mosaics on other servers and add them all to unified visualization server. At the receiving server, we choose the appropriate NDI identifier and add the stream as the incoming signal. The added signal service is displayed on the mosaic as one of the windows. All this allows you to distribute the load and display all UHD signals on one screen. You can also use the resulting mosaic in a larger display panel and so on. As a result, we are getting cascading when one large window includes many other smaller windows. The use of NDI in these tasks has several advantages, since it allows you to create a high-quality stream with minimal delay compared to other encoding methods. All this can be done within the standard network infrastructure. One of worldwide popular standards for terrestrial broadcasting is DVB-T2. An error in DVB-T2 signal feed to the transmitter can cause a failure of entire DVB-T2 network. For this reason, the established TR290 measurement guidelines have been expanded to include measurements for the new T2MI interface. For us, this task can be divided into two parts: analysis of T2MI stream and control of RF signal parameters, such as MER, BER, and so on. For the first task, our company has developed a T2MI de-encapsulator as a part of the MultiScreen server. This model de-encapsulates incoming DVB-T2MI stream to POPs, physical layer channels, and then decoded MPEG-TS streams are analyzed as usual. We support T2MI streams over IP as well as the DVB-SI using our in-house designed cards. Having the built-in de-encapsulator, we can demultiplex T2MI transport streams and control the syntax parameters of T2MI packets. To have all other parameters controlled, we made an integration with Navion Analyzer TNS 4200. Using data from this analyzer, we can get information about level and parameters of input signal, transfer parameters, SFN delay control, and real-time T2MI monitoring in accordance to the TR290. Based on this information, you can get complete overview on the distribution of T2 signal at physical, transport, and service layers. One more thing to notice. For demuxing of T2MI streams, we have a special standalone device called StreamLabs. At the moment, devices are available in two versions. One rack unit server with 2 ASI inputs and 4 IP outputs, and 3 rack unit servers with 2 ASI inputs and 8 IP outputs. This device also has a built-in remultiplexer, which allows you to create your own MPTS using services from the input stream. Next important direction in improving of our product is developing of SDI stream analysis. In addition to our own cards, we added support for decoding, as was previously stated. For improving the functionality of the cards itself, we added decoding of teletext and subtitles from SDI signal. This information is being transmitted in VBI and bank data according to specifications OP42 and OP47. Additional improvement was made in another type of bank data processing, namely in decoding of SCTE 104 marks. No one is interested in just receiving of SCTE 104 marks. It is important to disassemble their content. There are two types of messages. First type is a message that can contain only command, single operation message. Second type is a message that contains one or more commands, multiple operational message. Second type is more interesting for monitoring and analysis of commands included in a message. Quite often, head-end users a variety of parameters and identifiers. One for stations for ads insertion, another for determining of specific event in a playlist. Due to enhanced model for message parsing, we are now supporting the analysis of SCTE 104 not only for StreamLabs ingest cards, but for decoding cards as well. SCTE 104 marks are decoded in accordance with the standards, then processed and archived in the Stream MultiScreen database. We can visualize the SCTE 104 messages on the mosaic. In addition to detailed summary logs in MultiScreen, there is a new option to monitor the correctness of conversion of 104 marks to 35 marks for monitoring and logging of errors. Since a number of our partners switched to remote work, we decided to expand the variety of notification options available in our monitoring system. To make it simple and effective, we review the existing solution of mobile alerts. Quite popular and cost-saving way is to receive notifications from messengers. Opposite to SMS notifications, there is no dependency on mobile networks, and advanced IP API provides possibility to receive a feedback. Actually, due to widely used application, open API, support of group chats and channels, and an ability to request data from the multi-screen server, we have chosen to use the Telegram app for mobile notifications. This slide shows an integration diagram of Telegram alerts. Multi-screen server does not need direct access to the internet. You can install notification service on any PC, which has simultaneous access to the multi-screen database and internet. If there is no way to set up direct access, then you can use proxy. In order to make it work, you need to create a bot and a private chat on Telegram, and then register the chat ID in the settings for notification service. Detailed manual for creating and configuring of Telegram notifications is available on our technical support portal. Using the API, we can already receive all alarm messages from multi-screen server, request events for a specified period of time, request events sorted by service or by server. It is also possible to turn off repeated alerts of specific alarm for a designated period of time. We understand this functionality is in high demand now when we are forced into remote work. Therefore, at this time, we offer all our customers and partners to install a fully functional trial version. So if you want to try it out, please contact us by email through our website or our technical support team. We will continue to develop new functionality in upcoming versions of Telegram notification service. Okay, I finished introduction of multi-screen. You can ask your questions about this product now. After we finish questions and answers, I will start an introduction of MultiRec. Colleagues, yes,
I can see some questions here.
okay.
The first question, I missed some first minutes of the webinar and maybe already explained that. Multiscreen now supports decoding SDI inputs as sources, or signals must be converted in UDP, SMTP, and PTS, or HLS streams first.
That's the point. Any pre-conversions are not needed, actually. So we support monitoring of SDI signals itself. So no, you don't need to convert anything. You can just use the input SDI signals.
Okay, I see another question. I suppose it works also for SD and HD signals, not only for 4K UHD, 12G or 4x3 G SDI, correct?
Yeah, sure, it's correct. We've been supporting SD and HD SDI for a long time. And just recently, we have added the quad link and 12G. So now you can use them as well.
When do you expect to have updated documentation for multiscreen?
A good question. It's actually very important to have an updated documentation all the time. I think that the new documentation should be ready by the beginning of September.
Mm-hmm.
Anything else?
Yes, I see more questions here. Will you develop functionality for OTT monitoring?
Oh, yeah, sure. It's a very important task as well. In the near future, we finalize development of analyzer of OTT streams. But as of now, you can add HLS streams directly to the multi-screen.
Another question is, when do you plan to have web interface for multi-screen?
We will have it, I think, by the end of this year. Actually, it's in the roadmap, and we have an issue with the extended audit of users, and it will be solved. In addition, transfer of functionality to system configurator from multi-monitor will be solved as well. So we will move all the features directly to the web. So you won't need the application anymore.
Do you plan to support SRT?
Yes, sure. As a part of the OTT protocols, SRT will be also supported because this is a very improved technology of streaming for internet, very reliable protocol and very popular right now. I think it will be implemented in the fourth quarter of this year.
Some of my video inputs will have 8 channels of audio. How can I show all these audio channels on that Windows?
It's not a problem. It's just a matter of licensing. So you can have as many audio channels visualized as you need. So you can group it on the left, on the right, from the picture. It's all configurable, but basic license includes only a license for video and one audio, one P. I mean stereo audio. So if you have 8 channels, then you will just need to buy uh, additional licenses for audio monitoring. So if we don't have any questions for now about multi-screen, any more questions, then probably we can move to MultiRec.
1, 2, 3, gone. Let's switch to
Okay, let's move on. So, in many cases, besides the monitoring, signals from main broadcast station also need to be recorded. It makes easier to determine the weak link in case of failure. The product that helps to solve this task is called StreamLabs. In the next part, I will tell you about the new features of MultiRec, but first a few words about the system itself. StreamLabs is designed for multi-channel recording of any AV signal or transfer stream. The slide shows one of the typical setups of recording solution. The system consists of the following key components: StreamLabs recorders, database, storages, and web interface. Components can be installed on the same server or distributed over the local network, depending on the load and backup options. Here are the main advantages of our system. Web interface that allows working with the system remotely, what is so important today. User rights to give different levels of access for different users. The system provides a wide range of transcoding and burning options. Intelligent search of the video by fragment and uploaded sample. Restreaming of input signals, including delayed restreaming for time shifting. Automatic backups, email and SMS notifications model, and automatic recording triggered by multi-screen alarms. Next, I will briefly tell you about most important features, and after that we will move straight to new ones. The system has an option to group user accounts by roles. This means that one user can only view the content and another one can create, edit, or delete streams. In addition, for users who have only viewing rights, you can set the list of channels that will be available for them. While system administrator is adding channels for recording, he can choose one or two possible options. First is to record stream as is, or set live transcoding to lower resolution. Flexible settings allow choosing an appropriate quality for recording of video depending on the task. The system operates in a loop recording mode, which gives efficient use of disk space. Duration of recording can be set for each channel individually. There is also an option for graphics overlaying. You can overlay time, date, and any other text with custom fonts, sizes, colors, and designated position on the screen. Overlay can be done during recording or later during extraction from an archive. In order to make an additional large number of channels with the same settings more convenient, you can create and use your own templates. To set up a new storage with the same settings, simply choose needed template from the list and apply it. While creating the navigation interface, we took into account all the modern tools that are necessary for convenient work within archives. For example, a scalable timeline, which also indicates various events like start, stop, no signal, no record, advertisement detection, and others. Also, the system has a search by channel name and by alarm event. And there is a multifunctional player with various options. Start, stop, rewind, and playback. Volume control, change of speed of playback, frame by frame viewing for exact definition of a fragment, downloading fragments with refinement of selected area, viewing in full screen mode. MultiRec has a unique functionality for search of video fragments. It allows you to determine the presence of commercials in the video with duration from 1 second to 15 minutes. Efficiency is guaranteed even in case of a slight quality degradation, as well as for different frame resolutions. System allows you to search for a sample fragment in archive. Also, you can perform search in real time. It is widely used for an on-air blocks recognition. To increase efficiency, there is an option to specify both an image frame format and the search area on the video frame. An ad block recognition algorithm uses statistical approaches of parameters for selected content. These parameters are sensitive to changes of the level of informational component of audiovisual data. This algorithm is not tied to specific videos, and this is a major difference. This combined method brings the reliability of detection of ad blocks close to 100%. The system also has a multi-viewer option. You can view in two modes, real-time and playback of a specific fragment from an archive. It is necessary for visual analysis of several services at once. For example, when you need to determine the delay between different sources. Frame-by-frame viewing and changing the playback speed are also available here. The MultiRec stream can automatically extract fragments from an archive according to selected scenario. You can set up rules in scheduler and apply them either to one or to several repositories. It is possible to configure export settings for each rule, like file name mask, time for beginning of export, duration of the fragment, and metadata burning. These can be used for scheduling of recurrent export to a network folder or for importing by third-party recording system, which use certain naming conventions for fragments. You can also determine lifespan of recording independently from settings for the storage. MultiRec has a very useful option for automatic backup. During setup, you can specify the backup server for each storage. At the same time, we can use various redundancy schemes. It can be a classic N+1 scheme, when one server will be a backup for several recorders, or a scheme with mirrored N+N redundancy. We can also use a flexible approach to redundancy, such N+M. This feature, as is in the case of N+1, is achieved by setting priorities, calculating the maximum number of TV channels that the backup server can handle. We can increase the privilege for the number of TV channels that will queue for recording after the failure on the of the main recorders. In the redundancy system, there are also two criteria for switching to the backup. When the main recorder loses input streams, but at the same time it is possible to receive them on the backup server, and when the main server fails. In these cases, the backup server starts writing all the channels starting with a higher privilege. Privilege can be set and edited in the recording settings of the channels. This functionality is useful for automated continuous compliance recording. Also, there is a notification model, which allows you to send notifications over SMS, email, and SNMP. Types of alarms to be sent can be configured as well. MultiRec compliance recording system can work together with multi-screen monitoring system. This combination gives users several important benefits. Multi-screen alarm database can be integrated with MultiRec. This allows users to access needed fragments in an archive instantly. Also, there is a possibility of automatic extraction of recorded content to the network storage. Automatic export can be managed either by schedule or triggered by an alarm from the monitoring system. The list of alarms and thresholds for export can be set individually. Recording system can also work in automatic recording mode triggered by alarms from multi-screen. Both two systems can share the same ingest cards installed on a server. Well, that's all basic information about MultiRec. And now, what's new in MultiRec? First thing that we would like to share you with is that the system has got new modified unit for HLS recording. We have increased its stability in the latest versions of the protocol. When adding HLS, the system analyzes the master playlist, highlights the profiles, and allows you to add any of the profiles to the recording. The record can still be in its original quality as well as transcoded or overplayed with a date and text. Since OTT broadcasting is becoming more developed segment in TV industry, we are trying to keep it up and to date and improve algorithms for quality monitoring. For the tasks of synchronous recording, we added an input delay feature. It allows you to record video synchronously. It is applicable to situations when signals are received from different broadcast stations and combined in a single recording system for comparison and further analysis. Correspondingly, if you control several signals, for example, from a satellite or a cable operators with different time delays, this functionality will allow you to synchronize signals for further visual and quality monitoring. Now, more and more TV channels have several audio tracks on air, and it can be both language tracks and background noise To keep it safely stored after recording, we enhance the functionality of multi-track recording. In interface for recording, you can select the tracks that you want to hear. You don't need to record the stream in its original quality. It will be transcoded according to the settings which you selected. In the viewer interface, there is also a possibility of channel-by-channel listening. In addition to the full mode, we can play or extract a fragment only of right or left channel. This option is often used for analysis of audio fragment. For example, such as the search for DTMF signal in one of the channels or check for the reversed phase of advertisement marks. In order to increase the performance of MultiRec servers, we have added an option for hardware encoding. Addition of NVEnc encoder allows you to use the power of the NVIDIA graphics adapter for transcoding tasks. It works for UHD, HD, and regular SD channels. This allows you to expand the number of recordable channels on weak servers. The system can use several video cards. Then the load can be split between them by configuring in the web interface of the MultiRec system. We have also added functionality for processing DVB subtitles and teletext. Now MultiRec can put DVB-Teletext through or even burn on any of its pages while importing from an archive. In viewing mode, it is possible to turn on captions on or off. If you wish, you can force the subtitles to be burned over the video during the setup of the storage. In the early versions of the backup scheme, if you wanted to play back the video from the failed recorder, it was necessary to import its database onto any other MultiRec server. This approach caused some difficulties for user and slowed down the process. Since a unified MultiRec database has been implemented, the need for a separate deployment of a local database for playback has ceased. Now information about where the recorded chunk is stored is kept in a separate central server, which is accessible from any recorder. It also allows you to back up the system database separately in replication mode. Database can be located in a redundant storage system or on a separate server. It is also assumed that this can be one large data storage system with separate spaces for metadata and archive of media fragments. In addition to the new features which I described, we work in other areas. You can find information about other products on our websites or from our sales representatives. You may be already familiar with the products like vPlay, VRAC, MultiProp, MultiTuner. We are also preparing a launch of a new transport stream analyzer. We are also moving forward in telemedicine projects, and implementation of neural networks is under active development. My presentation is over, and I'll be happy to answer your questions. If you have them later or we won't have enough time to answer during the current session, then you can always send them to info@streamlabs.com. Okay, so what about the questions?
Two questions from Mr. Javed. Actually, I believe it's like two parts of one question. How do you detect the advertisement from the video feed? Do I need to burn in any code to detect the advertisement?
No. The search is based on a video sample that you upload. So it's a search by the sample fragment. So you upload an advertisement sample that you want to find in the recording, and it will just show up on the timeline where it was found. In case of live, this option is also available if you are transcoding the archive constantly.
Mr. Javed, did Ilya answer the question?
Yeah, you add a sample and the system detects it in archive, or live and displays on the timeline in addition to displaying. Oh, Eldar answered. Actually, Eldar already answered privately to Javed the question. Yeah.
Okay, I can see here a couple more questions.
So, I mean, just a second, Victor. So it means I have to keep on uploading every new ad every day. Well, if you need to find specific ads, then obviously yes, it's for, like, if you want to find in some recording how many times Coca-Cola advertisement appeared during the week. It's for something like this. So
okay, also,
yeah.
okay, Mr. Javed is satisfied. Now we have a question. Can they accomplish what the site will allow using your platform? Not clear what this question. Can I accomplish what this site will allow using this platform?
Using your platform.
Yes. You should be able to accomplish.
No, I just have a look.
All right, so
It's a question about can we do the
about the
same.
platform on the website. I see.
Well, actually, it's a partly question for another webinar about vPlay, I think. So, if I have a look, producer, create, embed, grow. Well, basically, yes. Answering for vPlay, vPlay supports almost all the features that are shown on this website. So I think yes. Anyway, you can always try it out. It's free and 1 month fully functional.
We have a couple more questions about MultiRec. Is all this new function available on a new version of vPlay or Stream MultiRec? Is a new standalone system?
Yeah, again, we have some kind of mix-up. No, it's 3 different products for different tasks. So MultiRec, again, MultiRec is for compliance recording, looped recording. And vPlay is a playout. So that's what I think was asked a few seconds before by Alicia. So I think we can try to solve your task, and just send us a request to info@stream-labs.com with the task you want to solve, and we will think what we can do, how we can help you. Because I didn't clearly get the site would be stream.com. Okay. Any more questions?
Yes, there is one more question. Is there a possibility for hardware processing of input signals?
Yeah, as I mentioned, we support NVIDIA and VEnc, and currently there is a basket of cards which we support. Almost all NVIDIA types. They may vary, like 1050, 1060, 1050 Ti, Quadro, Tesla, whatever. Just it depends on the how many channels do you want to transcode. So all of these cards are used for transcoding, especially for UHD and HD channels. Okay, what else? If we don't have any more questions, then probably we can finish. We will be happy if you take a look at our other products, which can be useful for your work. Anyway, thank you for your attention. Take care. Have a nice day. A nice ending of the working week. So, okay. Thank you, everybody. See you next time on next webinar. We will let you know accordingly when it will be held.